Hello, grade 11s. Today's lesson is on the ideal gas law. The ideal gas law relates the pressure, volume, and temperature of a gas to how much gas we have in the container to begin with. Our other gas laws all talked about how one of our variables would change if the other variables change. In this gas law, we're not looking at how the situation is going to change. We're looking at what is the situation in this instance. P is still going to be pressure, and V will be volume. We recognize this already. T is still temperature, but we have two new variables here. We have N and R. Now, N talks about the number of moles of gas that we put in the container, how much we put in there. A mole is a group. It's saying how many groups of atoms of gas do we have in that container. It's a group that has a lot of particles in it. There's all kinds of groups we use in chemistry and in life. We can use the group of a dozen. We know it would have 12 pieces. The grouping called a mole has 602,000 million pieces. We're not going to worry about that too much here. I'll have another video up about what a mole is and how to understand it. But for right now, we're just going to think about the moles as the number of groups of molecules of gas that we have. So if I put more groups, more amount of gas in a container, if I blow more air into my balloon, the balloon will get bigger, so the volume will go up, and the pressure inside the balloon obviously will go up. There's a relationship between how much air I push into a container and the volume that the container takes and the pressure, and that relationship is direct. And when we have a direct relationship, we divide. If I take pressure and volume multiplied together, I can divide by both temperature and the number of moles. And if I do that, I get a constant called R. R is called the ideal gas constant. And the value for R could vary dramatically depending on whether or not our pressure is measured in millimeters mercury or atmospheres or kilopascals, because even at standard pressure, those numbers are very, very different. So when we use ideal gas law to try to calculate how much pressure, volume, or moles is going on in a situation, the rules that we follow are listed. The volume is going to have to be measured in liters. If I've given it to you in milliliters, you're going to have to change that to liters first. Temperature has to be in the unit of kelvins. Now that's been true through the entire unit, so there's no big surprise there. But again, depending on the value that we use for pressure, the number that we'd have to substitute for R is going to change dramatically. So if our pressure is measured in atmospheres, the value that we get for R is 0.082. Now this is a constant. Anytime pressure is in atmospheres, the value for R would be 0.082. If our pressure is measured in millimeters mercury, the value for R would be 62.4. And if we're measuring in kilopascals, we use 8.31. Now you're not going to have to memorize these numbers. They're on the back of your green periodic table / cheat sheets that I've given you. And what you always want to do is match first which units of pressure that the question has, and then use the appropriate value for R. Traditionally, we're going to write the ideal gas law in this fashion. PV equals nRT, where pressure and volume multiplied together are equal to the product of the number of moles times that gas constant times temperature. So we've basically just rearranged the equation from the previous page. So from this equation, we've got some pretty simple math to do, because all of my questions basically will give you 4 of the 5 variables and say solve for the unknown. Let's take a look at an example. This is a great example of an ideal gas law problem. I know it's an ideal gas law problem, first of all, because I can see right off the top they're asking me for moles. And the only gas law that we have that has moles, N, is the ideal gas law. But also, I'm finding only one instance of volume or temperature or pressure. There's not multiple instances here. Nothing's changing. So let's take a read through and find all the numbers with their units and see if we can identify what they might be describing. A sample of a gas has a mass of 2.1025 grams. Now, grams is mass. It's not moles. Moles, again, is a group. If I have a group of 10 eggs, it would weigh one amount. If I had a group of 10 kids, it would weigh a very different amount. So we know a mass here. So I'm just going to label this as my mass, and I've got that value. It's found to occupy 2.850 liters. Well, I know liters. Liters measures volume. At 22 degrees Celsius is temperature. Of course, we have to change that right away to kelvins by adding 273 to it. And we are at 740 millimeters of mercury, and there is my unit for pressure, 740. Now, the question this time actually gives us the value we're going to use in place of R, which is great. A lot of times I won't. What I need you to do is look at the units for the pressure. We're giving you the units millimeters of mercury. So what I'm going to need you to do is to go to your cheat sheets and look up which R value do I use when pressure is in millimeters mercury, and it will tell you 62.4. So always step one is to write our formula. PV equals nRT. And as usual, I'm going to give you a mark just for doing that part. Substituting pressure, volume, the gas constant, and temperature, and then solving for N, we get a value of 0.115 moles. So we're just shy of a whole mole. We're shy of one whole group. We're at a fraction of a grouping. That's how many moles we have. Well, what do we do with the mass? In this case, we wouldn't do anything. This is an example of a question offering us some extra information. Do you know the difference between moles and grams, between what's called a group and how heavy it is? Again, if you're having problems with the concept of a mole, go watch my video on Introduction to Moles. Let's do just one more example. Suppose we want to calculate the volume. There's a question. Calculate the volume. That's our unknown. We're given 3 moles of a gas. So 3 moles is my value for N. How much will it occupy? At 24 degrees Celsius. Well, there's my temperature. Again, when we have a value in degrees Celsius, change it to kelvins right away. And we've got a pressure of 9 kilopascals. So there's my pressure. Now, again, as soon as I see moles, I know that we have a PV equals nRT formula. In this case, I did not give you the value for R. If you go now to your green periodic table cheat sheets and look in the box that has our gas constants, you will see that when we are measuring in kilopascals, the value we use in place of R is 8.31. Again, let's substitute. Pressure was 9 kilopascals. The volume we don't know. We'll see that as our unknown. The number of moles was 3. The gas constant we're picking is 8.31, and the temperature in kelvins is 297. 3 times 8.31 times 297 divided by 9 gets V by itself, and we get a value of 823 liters. Remember, volume in these formulas will always be in liters. I'm going to need you guys to practice using the ideal gas law formula. When you're done, I want you to know if you can identify what each of the variables mean in the formula PV equals nRT. Can you determine which number to use in place of R by matching it to the units that were given for the pressure? Can you explain why temperature must always be in the units of kelvins for gas law calculations? And can you use our ideal gas law to calculate temperature, pressure, and volume? I have lots of practice problems available for you guys on pages 29 to 33 in your green work booklets. And shortly thereafter, sometime, we're going to be doing a unit assessment on this, because this ends the last of the gas laws that we are going to cover in this particular unit. As always, please feel free to message me if you have any questions at all.